Hello, this is Timmy. Welcome to Jackass.
Let me record it.
Alright, today we are going to be explaining the first law of thermodynamics. Now, the definition of this term is energy can always be transformed or changed from one form to another, but it can never be destroyed.
Man, Timmy, you suck.
What did you say?
I said you suck. Oh, you motherfucker. So the first law of thermodynamics can also can be related to math, and in this equation delta U, and that is the change in the system's internal energy, and that equals Q, the energy transferred to or from a system as heat, minus your W, which is your energy transferred to or from a system of work.
Nope.
Nope. Nope.
Go.
I'm going to show you deep sea air conditioning and how it ties into first law of thermodynamics. Nope. I'm going to show you an example of deep sea air conditioning. It's of the first law, and there's a pipe down deep in the sea, and it takes up the cold water that's below freezing, goes up, and the pump pumps up to the heat exchanger, and at the same time the building's warm fresh water moves into the heat exchanger, and they're both in there, and the seawater cools the fresh water, and the fresh water comes out cool and goes in the building to make AC cool, and then the seawater becomes warm and is deposited into the ground.
Alright, there you have it. Deep sea air conditioning and how it ties into the first law of thermodynamics.
Alright, Jerry, stop.
Okay, now the deep sea air conditioning is a good example of the first law of thermodynamics because you can see that energy is neither being created nor destroyed because the cool water comes up from the ocean and eventually goes all the way through the system and comes out back into the ocean as warm water, and the fresh water from the building keeps cycling through and through the system. Go.
Hello everyone, I will be explaining heat engines. For the slower one in the class, Dylan, you will have to pay attention more carefully. Heat engines use heat to do work. A refrigerator uses mechanical work to create a difference in temperature and thus transfers energy as heat. A heat engine is a device that does the opposite. It uses heat to do mechanical work. One analogy for heat engine is a water wheel. A water wheel uses the energy of water flowing from one level of Earth's surface to another. The change in potential energy increases the water's kinetic energy so that the water can do work on one side of the wheel and thus turn it. The greater the difference between the initial and the final values of the potential energy, the greater the amount of work can be done. Instead of using the difference in potential energy to do the work, heat engines do work by transferring energy from a high temperature substance to a lower temperature substance. And as indicated for the steam engine shown in figure 11, for each complete cycle of the heat engine, the net work done will equal the difference between the energy transferred as heat from a high temperature substance to the engine, and the energy transferred as heat from the engine to a lower temperature substance.
Go.
So, Dylan, this is a perfect example of the first law of thermodynamics.
Go.
So, Dylan, this is a perfect example of the first law of thermodynamics because as the temperature is going in, it is at a higher...
Stop.
Go.
So, Dylan, this is a perfect example of the first law of thermodynamics because as a heat engine is able to transfer... God damn it. So, Dylan, this is a perfect example of the first law of thermodynamics because a heat engine is able to do work by transferring energy from a high temperature substance to a low temperature substance. Therefore, energy is neither created nor destroyed, it is just transferred.
Done. Timmy Sharpman.
Boom! 360! Hey Ross, golf is...
Nate Hill.
Hey Conrad, is this shirt tight enough for you?
Chris Neely.
Ben Cohn really smells.
Joey Sharpman. God, it's cold out here.